Hello friends, I am Vidya Patil, Assistant Professor in Department of Mechanical Engineering in Sharad Institute of Technology Polytechnic Yatra. Today we are going to continue our fifth unit of Refrigeration and Air Conditioning for the subject Power Engineering and Refrigeration. In this session we are going to cover the window air conditioning system, split air conditioner system. We see the difference between split and window air conditioner. Also we see the central air conditioning system, and again we see the difference between central and unitary air conditioning system. We start from window air conditioning system. Okay, window air conditionings are the one of the most commonly used and cheapest type of air conditioners. Okay, to install one of these unit, we need to space to make a slot in wall, and there should be also some open space behind the wall. Okay, so in room air conditioner mounted in lower hung of window, and window air conditioning small unit having capacity 3 by 4, 1 1 1.5 2 or 2.5 ton, and usually do not incorporate heating capacity, and it is usually capable of cleaning air, cooling air, distributing air, and dehumidifying air. So in ventilation is also provided in a window air conditioner to provide fresh air. So the basic components for this system are filter, accumulator, capillary, thermostat, evaporator, and evaporator fan, condenser, condenser fan, and fan motor, okay, with controls. So here in this figure also we can see the window air conditioning, that room air conditionings are familiar to most of us, and these Ablicus machines can be seen mounted in windows and therefore are also referred to as a window air conditioner. So in window air conditioners, the compressor, condenser fan, all these are enclosed in a single cabinet, and the unit is to be installed in wooden frame, so either in window or in a hole in the wall. Okay, now we see the working of this window air conditioner. Here in this figure we can see the room or window air conditioner system. The working cycle of this vapor compression cycle, and high pressure high temperature refrigerant vapor coming out of compressor is condensed in condenser using outside air as a cooling medium, and also the liquid refrigerant from the condenser passes through the dryer filter having silica gel capsule, where it absorbs any moisture in the refrigerants. The liquid refrigerant is further passed through the capillary to reduce pressure, and then passed to the evaporator, where it absorbs heat from air producing cooling effect, and due to the absorption of heat, liquid refrigerant converts into vapor, and vapors are drawn into compressor. So the cycle is repeated again and again, and if air is cooled below dew point, dehumidification of air take place, and extracted moisture are removed, okay, from the back side of the window air conditioner. So this window air conditioner has three separate air circuits. First is the room air over evaporator, second is outside air over condenser, and third is the outdoor fresh air circuit. Okay, so here the room air or evaporator, in air from the room is drawn into that unit through the filter, and that removes dust and impurities. Also it passes over thermostat and evaporator coil. So thermostat measures the temperature, and if it is above the set level, it switch on the compressor. If it finds temperature below the set level, that switches off the compressor. So the air passes over evaporator coil, where it is cooled and once again supplied to the room. It is all about room air over evaporator. Next, window air conditioning, next unit of circuit, that is outside air over condenser. Here the air is drawn into the unit from outdoor and passed over air cool condenser. And next is the outdoor fresh air circuit. Okay, here the occupant load increases, it requires fresh outdoor air to maintain the purity of air. So this can be done by providing fresh air damper and ventilation switch. In also there is a master control and thermostat control also. In master control starts and stops the fan and compressor, and the occupants uses this control to choose the desired operation like cool and ventilate, and to select the fan speed. So it provided with low, medium and high speed for fan and low, medium or high cooling. Also thermostat control is also available there. For the thermostat element in window air conditioner is usually located in return stream of the air near the filter where the thermostat control is placed. Okay, so the location of this window air conditioner is located on north pole so that it does not get direct sunlight. Also for the room where there is no choice of location, and if it is exposed to west or south also, and the unit will be directly exposed to the sun rays, and in such a cases shade must be provided so that it will not directly exposed to sunlight. So direct sunlight tends to increase the condensing temperature and operating cost, and thus reduces the efficiency and capacity. So for the installation of window air conditioner, there are some steps which are used to installation of window air conditioner. That is remove the air conditioner from crate. Also read installation instructions provided by the manufacturer. Also note the voltage stamped on air conditioner and compare it with voltage of power plug. Also if required provide stabilizer. Test and operate the air conditioner. Select the suitable window, preferably on north wall. Make the slot of required size. Insert air conditioning cover in slot and fix it with the help of 3x4 screws. So insert the air conditioning into cover. Check the level of air conditioner in windows, and air conditioner should slope towards the outside about 1.5 centimeter in 1 meter length. So this ensure the flow of condensed water from evaporator to cylinder ring. Also required to give angle support from outside and feed the filter and front grill of air conditioner. Also seal the gap in windows and make the room tight, airtight. So connect the air conditioner with power plug, switch on machine and check it performance. These are the all installation steps of window air conditioner. Now we see next is the split air conditioner. As we know, the name indicates here that split air conditioner is a window air conditioner with two different sections mounted inside and outside room respectively. So the indoor section consists evaporator coil, evaporator blower with motor and capillary tube, control panel, air filter and return and air supply grills. Okay, so this indoor section is mounted in room to be air conditioner. So it can be wall mounted, ceiling suspended or kept on floor. So in outdoor section consist of parts like compressor, air cooled condenser, condenser fan with its motor. So this outdoor section is mounted outside with its motor. So outdoor section is mounted outside the room, and these two sections are factory assembled. So after installing indoor and outdoor sections, these are connected by liquid and suction line of the refrigeration system laid at site. So after installing the unit, pressure testing, evacuation, charging of refrigeration system is done, and the distance between indoor and outdoor section is kept as small as possible. And as a distance increases, pressure drop in suction and liquid line increases, so decreasing capacity and coefficient of performance of the unit. And the noise making equipment like compressor is locked outside the room, and therefore noise of system is totally eliminated and system is quiet. So therefore for soundproof operations, split air conditionings are preferred. Okay, here in this figure also we can see the condenser compressor that is outside space, and in the inside there evaporator coil with fan and conditioned room are placed. In conditioned room are placed. So there are types of indoor units are floor mounted, high wall splits. Okay, in floor mounted, such units are mounted on the floor and maybe on a platform. Air through is upwards, and since floor space is premium and floor mounted units occupy real estate, such indoor units are not very widely used in these days. So next is a high wall splits, also ceiling mounted. In ceiling mounted split, air conditioners are designed to be suspended from the main ceiling. There are three models. In first is exposed, second is concealed, and third is semi concealed. So in exposed, units are fixed directly to the ceiling and are visible. So the unit is similar to the floor mounted type, and they are easy to mount, and they are preferred in commercial areas or offices that do not have false ceiling. Okay, next is concealed. These units are also mounted on the ceiling but are designed to be hidden, so they are generally concealed by the panel box or false ceiling, and these units are suitable for commercial areas where the interior designer requires the air conditioning equipment to be concealed so as not to interface with the aesthetics. So you will find the such units working in restaurants and offices also. Next is a cassette. Okay, this type of indoor units are mounted above the false ceiling in such a way that the outlet grill of the unit is flush with the bottom of the false ceiling. And while the other types of indoor units provide for condensate draining by gravity, the same is not possible for the cassette type. And this cassette also has the advantage that it can be placed directly above the specific areas that require air conditioning, and multiple units can air conditioning larger spaces are required. Now we see the centralized air conditioning systems. In centralized air conditioning systems, all components are grouped together at central control room, where the air is processed and distributed through duct to various rooms in building. So all the rooms in buildings are air conditioned by central air conditioning plant, and control rooms may be located in basement or suitable corner in building. So it is generally used for capacity more than 40 tons of refrigeration. The central air conditioning plant consists of reciprocating compressor and its motor, water cooled condenser, air handling unit with cooling coil and throttling devices and interconnecting piping. So these all components are carefully selected and field installed. So this condensing unit, that is compressor motor, condenser are located in control room. So air handling unit is located at geometric center of this building, from which conditioned air is distributed to various rooms. Also, to distribute the air to various rooms, duct design and laying is done carefully to minimize the losses. Okay, in central air conditioning systems, that can be divided in two main groups, that is direct expansion type and second is indirect type, that is also called chilled water system. Okay, in direct expansion type, the air from the space to be air conditioned is circulated through the cooling coil and which is cooled by refrigeration cycle, and the liquid refrigerant at low pressure absorbs the heat from air and get converted in vapor. Therefore that is called direct expansion system. And the cooling coil or of refrigeration plant is fixed in air handling unit, and the expansion valve is provided very close to the cooling coil in direct expansion type. In indirect expansion type, the chilled water or brine is circulated through the cooling coil located in air handling unit to cool the room, and the chiller in the chiller package and the cooling coil in an air handling unit are connected by the chilled water, so for or brine pipes to pump. So the pump circulates the chilled water or brine between chiller and cooling coils. Okay, here in this figure also we can see the central air conditioning system having compressor motor, chiller, condenser, chiller pump, air handling unit, okay, condenser pump. Okay, these all we can see one by one. Now we see the central air conditioning system that are classified in all air systems, all water systems and air water system. First there is a all air system. Here we can see these systems all are working medium is a only air. Okay, so in outdoor air goes to the cooling coils, okay, and through the damper, and these after the cooling coil goes to the heating coil, and after that goes supply air duct with fan to the humidifier, and after humidification they goes to the conditioned space. Okay, and after that the outlet of this conditioned space goes to return air duct with fan to the circulated air through damper to the exhaust air. Okay, all this system is used only air as a medium. Okay, but the next here, these are advantages of this all air type system, that is, it is possible to use a wide variety of air filters and avoid noise in conditioned space. Also the complete absence of drain pipes, electric and filters at the conditioned space. Also in this case dual duct systems is possible to provide and simultaneous cooling and heating. So seasonal change over is very simple and easy to automate. So it is very flexible, heating and cooling can occur in different zones simultaneously. But there are some disadvantages also of this system, that it requires more space, reduce the available floor space, and also due to the space constraints it may be difficult to provide air conditioning at high rise buildings with the plant on ground floor or basement. Okay, and also due to the space requirement retrofitting may not be always be possible here, and balancing of air may be difficult in case of large and particularly with variable air volume systems. Okay, next system is all water system. Here we in this figure also we can see there is a supply of cooling or heating coil, only water. The conditional zone 1, 2 and zone 3 are there, and there is a water flow controls walls are situated to supply the flow of water, and after the outlet of this condition zone 1 2 3 goes to the return water line. Okay, these all water is used as a medium, and the advantage of this system is this plant size is small due to the absence of large supply air fans. Okay, air fans is not here, absent of air fans, and easier to retrofit to existing building. So thermal distribution system requires very less space compared to the all air systems. Okay, or solar or waste heat can be utilized for winter heating. Also there are some disadvantages, that are filters are small, require higher maintenance compared to the air system. Also, ventilation depends on wind, and hence it is difficult to ensure positive ventilation under all circumstances. Also, and control of humidity, particularly during summer, is difficult using chilled water control valves. Next is the air water system. Here air and water both are used. Here central plant for secondary water also, and central plant for primary air also. Okay, and goes here there are supply lines with pump for the central water for water secondary water, and supply duct with fan to the primary air, and secondary water goes to the primary air, goes to the conditioned room, and again here primary air goes to the conditioned room, and again return duct for the central plant, and return water to the central plant for secondary water. Okay, this all circulation we can here you can shown in with arrow. So advantages and disadvantages also given for this air water system, that are rooms can be individually controlled at relatively low cost, which control either the secondary water flow rate or the secondary air or both. Also, the amount of primary air supplied is less than that of an air systems, therefore space requirement is reduced here, and there is no latent heat transfer is required in cooling coil placed in conditioned space, and its life therefore increases. Also, the terminal units in case of induction unit does not have fans, motors or compressors, and hence service of the indoor unit is relatively simpler compared to the all water systems. So the disadvantages are need of handling and controlling of both air and water operation and controls are complicated, and the water coils in the conditioned space can become dirty if the quality of the filters used in room units is not good. Also, the initial cost could be high compared to the all air systems, and shutting down the supply of primary air to occupied space is not possible, because constant amount of primary air is supplied to the conditioned space, and room controls is only through the control of room cooling or heating coils. Okay, this is all about air systems, air system, water system, and air and water system for the central air conditioning systems. Now we see the difference between split and window air conditioner. Here in split air conditioner, it is quiet in operation, and window air conditioner is noisy in operation. And in split air conditioner, indoor and outdoor unit is connected by liquid and vapor line, but in window air conditioner, console unit is mounted on a seal of window. So charging is done after installation in split air conditioner, and in window air conditioner it is purchased unit and can be directly installed and operated. The cost of split air conditioner is more, and cost of window air conditioner is less. Next is the difference between central and unitary air conditioning system. In central air conditioning system, the ton capacity is more than 40 tons of refrigeration, and in unitary that is 25 tons of refrigeration. The mass flow rate of air handled is around 2000 meter cube per minute in central air conditioning, and mass flow rate of air handled is less. So all rooms are required to be maintained at more or less similar condition, and here in unitary only the each room can be maintained at different conditions. So in central air conditioning is located in basement or outside the building, and unitary air conditioning located in every room, so which required to be air conditioned. So central air conditioning is quiet in operation, as noise making components are located outside. So in unitary air conditioning may be noisy, and it is quiet in operation, and it is used as a split unit. Also, in central air conditioning, it requires duct design and installation, but in a no duct design installation is required in unitary air conditioning system. So the capital cost of central air conditioning equipment is less, and capital cost of unitary air conditioning is more. Also, one person can look after entire air conditioning plant. Maintenance is convenient and easy, but the maintenance and accessibility is difficult for the unitary air conditioning system. Also, if air conditioning in particular room is not required, and it cannot be switched off in central, but if not required air conditioning of particular room, it can be switched off is possible in unitary air conditioning. So there is a failure or fault in air conditioning plant, air conditioning of all rooms is affected in central air conditioning system. But if any there is a failure or only air condition there is fault, that time only air conditioning of that room is affected, not for all rooms are affected like central air conditioning system. Okay, in this session we cover window air conditioning, split air conditioning, and central air conditioning systems and differences between them. Okay, thank you.